Okay, so good morning all and welcome back to the session. This is Generative AI Masterclass. Uh, so friends, what we have seen so far, we have gone through with GenAI basics and from the basics perspective, we try to go through with the theory part, like what generative AI is and what are the different you can say phases, say pre-training, fine-tuning, and all those particular things we have discussed. Then we have started the simple inference with the help of large language models. And what we are trying to do, we are trying to perform some simple task. Say we have done the sentiment analysis where we have given certain data to the large language model, and based upon that data we try to get the insight in terms of sentiment. Is it a positive one or is it a negative one? So those particular things we have seen inside the sentiment analysis. Summarization, this is working in such a way that if you are having a big paragraph or huge content and you just want to have the summarization into say few lines, then you can utilize it. So summarization is working that particular way. Question and answer, so you can ask questions. It might be from the given context or you can utilize the LLM intelligence as well. So that is nothing but the question and answering. Fill mask is working uh, in such a way that like fill in the blanks. So mask is treated as a blanks position where LLM is trying to fit a correct word, and we have seen it practically as well. Then translation is something, say if you have certain content in one language, how you can convert it into the different language. It might be say French, Hindi. So we have seen we have gone through with say default models, and we try to translate the given content into the different language. So up to so far we have performed these particular tasks with the help of large language models. And what is the basic thing that we have seen in these particular tasks? First one is, say, inference based upon the default model. And second, what we have seen, inference based upon the custom model. And once I'm mentioning, say, model, it means large language model. LLM only. I'm talking about LLM only over here. Okay. And in this particular practical, if you are able to see, I have specified a model. This is nothing but the custom model. Helsinki NLP Opus MT English to French. So this particular model is going to convert your given, you can say, content into French. Say, how are you? What I can do for you? Okay, so it has converted it into the bonjour, comment, alias, versus. So this is in French. Probably I'm not pronouncing it well, but yeah, our large language model is able to convert it into the you can say different language what we are going to mention. So these are the things what we have seen in our previous sessions, and the intent was to go through with certain tasks with the help of available large language models. Okay, and that is nothing but the inference only, like how you will be able to do the inference. What is the meaning of inference? It means utilization of large language model. Inference means of LLM to get some output. Okay, so you can take it into this particular way. You are having say input, you are using LLM, and you are getting the output. And this piece is known as inference. This is a inference process. And we have seen it can be done into two ways. How you can do it can be done into two ways. What are the two ways? I have discussed it in our previous session. What are the two ways? Can someone explain? Hmm? Different ways to inference. Hmm. Because
Uh, so,
mhm.
sorry, I did not. That's different. Forget. I need to check, Asok. I think I forget
Okay.
that.
This is very simple, guys. So inference, what it means, say using APIs. Okay. And second one is download the LLM locally on your machine. Okay. So at this moment, what we are doing, we are downloading the large language models locally on our machine. If you are able to see over here, probably we can check different example where we will be able to see the downloading fees and all. Hmm, it is taking some time. Okay, so so over here, if you are able to see, no model was supplied defaulted to this particular model using the pipeline without specifying a model name. So what exactly is being happening over here? We are using this particular model, okay, Distilbert hyphen CNN 12 hyphen 6. So this model is being utilized. Although this particular model is available in my machine, so that the downloading was not happened over here, but if I'm going to say specify just let me try to perform certain tasks, then you will be able to see the model will be downloaded onto my machine and then will proceed further. So I'm going to perform certain tasks and certain more tasks basically with the help of large language model, and probably we will be able to see uh, the model downloading. Okay, so now what I'm going to do, I'm going to perform the feature extraction. And what do you mean by feature extraction? What do you mean by feature extraction?
Uh,
Hmm. Can someone try? Mm-hmm. Okay, so let me try to do it, and then you need to tell me like what exactly is being happening. Huh? I'm trying to give you one more time. Okay, so what I can do inside the feature extraction, I can define as a extractor that is going to extract the feature, and probably I'm having the pipeline. Are you pipeline? This is basically utilized from here the transformer framework. So pipeline is there, and what I will do, I will say specify the task as feature extraction. Feature extraction. This is the task, and the model. Let me try to check, or let me keep it blank only. This is the extractor, and let me try to have the execution of it. Pipeline is not defined, so probably this is not executed. Let me have the execution of it. So first, like what we will do, we will try to move with the default model, like which is the model for a default, which is the default model for feature extraction. At this moment, we haven't specified the model. Okay, so we are specifying the task only, and based upon this particular task, there are certain default models, and that particular model will be picked over here. Huh? I haven't specified that particular model. Even what I can do, I can check onto this is the Hugging Face and feature extraction. Huh? So you can see CTFM feature extractor. This is a model. This model is a feature extractor of CTFM, a model pre-trained using contract contrastive self-supervised learning on huge data set. This is the data set. CT scan information. Okay, it is having CT scan related information. And if I just want to do is something there for inference. So direct inference provider, say, let me click onto the new inference provider. If I'm able to do the inference, direct inference is not possible over here. We just need to utilize the feature extractor. I can take it into this way. So this is the, let me check the models. Locate anything, text generation. So over here, multimodal, computer vision, image to image, we will be able to see the different tasks related things over here, video classification, text classification, natural language, feature extraction probably available somewhere over here only. Feature extraction, okay. And these are the models for feature extraction, okay. Q prime, Harrier OSS V1. Okay, and let me try to say pick the first one. And do we have direct inference over here? Downloaded last month. No. Microsoft Harrier. Okay. Can I do inference over here? Mess. Okay. So just have a look over here. Inference provider feature extraction, and what it will give. Hello, how are you? Okay, and let me see generate. Okay, so what did you get over here?
I think we can get the dimension tokens minus plus.
Uh,
So
uh,
uh,
what? Tokens?
no, no, positive negatives, na. We need to
Uh,
consider the positives values only. Uh,
uh,
uh, uh,
okay. Huh. So, hello, how are you? Okay. So, hello, how are you? And this is a try to recall. I have given five, oh, sorry, four words over here, and with respect to these particular four words, I'm able to see the embeddings, correct? And these particular embeddings are having these particular dimensions. If I'm using say Harrier OSS V1 270M, 270 billion, okay, zero point 0.6 billion, 27 billion. This is the dimension. So hello is having these particular embeddings with respect to the different conditions. Are you able to recall?
yes, now recall. Yeah,
Okay.
embedding word I forget. Mhm, correct.
Okay. And over here we are able to see two things. And you can ask the questions if you are not able to get anything at any point of time. So what I'm doing over here, I have just written a particular sentence and I'm fetching its embedding information. Okay, feature extraction, you can take it into this way. It is going to fetch the embeddings for your given content. And embeddings will be with respect to the dimensions what you guys are having. I know, like the dimensions embedding, these are the new words for the new members. Okay, but for say Vikas and probably Yogendra, you guys are having the information about embeddings. But no need to worry. The thing is that over here I'm extracting these particular embedding, that is perfectly fine, and I'm having certain tokens as well with respect to each, you can say, stuff. Not tokens, but what I can say, these are the uh, these are the, you can say, information with respect to each and every tokens. Say hello, how are you, and probably this particular model is being utilized over here, and we are able to see 1023, you can say. Over here we are having 1024 total, you can say, dimension. So 0 to 1023 we are having 1024 embeddings for a particular given token. Okay, what we are doing over here, uh, we are performing the embedding through API. Yeah, okay, it means processing is happening onto remote machine. Processing happens on local machine. Are you able to get what is the difference between, say, the API inference based upon API and based upon the downloaded model?
Yes, Ashok. Understood.
LLM on local. Okay, these are the two ways basically to utilize a particular large language model or to do the inference based upon the large language model. Okay, so we can have the another way as well, but that is more or less similar to say this second piece. What you can do, you can say, if you are working in an organization and you don't want to expose your data to outside world, what you can do, you can have a large language model. Okay, you can download it, and you can set up a server on top of that particular large language model, and then through API call you can provide the access to that particular server, so that all the people in your organization will be able to use that particular LLM, and that can be the heavy machine which will perform the processing. It is not like say model will be downloaded on the local of every employee, and then they need to perform the inference at that moment. Like the processing will be huge, and the processing will happen onto every employee machine. But once you download a LLM, and it might be possible that you are going to fine tune it with respect to your organization data, and then set up a server where you can connect to the different users with the help of APIs. Are you able to visualize, all of you, what I'm mentioning over here? Are you able to visualize?
Yes, yes.
Let me ask. Okay, Anurag, are you able to get pin, especially both of you? Are you able to get what I have mentioned?
Hello, Ashok.
Voice is not
Right
clear,
in Bay Area,
Anurag.
actually, currently. So my process is actually it's getting it's very slow actually. Sometimes I'm missing like
Uh,
hello,
Anurag, I'm not able to hear you properly.
hello. So
Mhm. Your voice is low.
yeah, actually I'm in Bay Area. So most of the network is going down.
Guys, is it with you as well? Are you able to
Yeah.
hear Anurag properly?
No, no, we can't hear.
Some yeah, actually it's a breaking your voice up.
Anurag, I think some connectivity issue is there at your side. I think you need to check the connection. Vipin, what about you? Are you able to understand what I'm mentioning over here?
Yes, it is.
Okay, perfect. So, we can use the LLMs with APIs, and we can download it onto our machine. What we have seen, we are having different, you can say, LLMs, and LLMs, and there are different LLMs for the feature extraction. This is the task what I have mentioned, say feature extraction, and I try to do the inference with the help of APIs over here. I just mentioned the text. I don't know like where this particular LLM is configured, but with the help of this Hugging Face Inference API, if you are able to see, API is mentioned. Okay, Hugging Face Inference API. So I just want to do the inference with API. So I have just mentioned the text over there. Or what can be the another option? Download it in our local machine. So just have a look. It is ready, and let me try to have the execution. So pipeline feature extraction. So what it is saying, feature extraction unknown task. Now probably the spelling mistake is there. Let me copy from here. Feature extraction. Okay. So spelling mistake was there. And so just have a look. It is saying, say, no model was supplied, and I'm using Distilbert base uncased. So somewhere like it, this particular LLM is there in my machine. Probably it was downloaded earlier. What I can do, I can first do the inference based upon this default model which is being picked, and then we will try to use or download a different model on our local machine. Then we'll do the inference with the help of that model. But say what I can do, I can write a text, and I will write the same text. Say Hello. Oh, are you? Okay, so this is what I have mentioned as a text. And what I will do, I will try to do the inference based upon this. So I can have a result ext. Okay, that is for extraction result. I set a variable, and what I can do, I can take this extractor and pass my text what I'm having over here from this particular extractor, and this will be the result, and I can print the result. Okay, so print result underscore ext, and just have a look. Okay, are you able to get the same stuff? And these are nothing but the embeddings. Probably you guys are not having the information like what is this embedding, but like you will get enough understanding. I just want to do like there is certain thing respect to say embedding, but what exactly is embedding, we will be going to have a discussion in our upcoming sessions. So we can try to print the length of this, and this is a class basically. Okay, what I can do it if I just need to print in that particular way. So what I will do, import numpy.
I think we can print as a shape. We can pass the shape.
Print as a
We can pass the shape now, so we can get the dimension and all.
I'm trying to do in a little bit the different way. Embedding equal to then we don't mean and say result of 0. And length of embedding. Okay. 768. And what I want to show, I just need to use this particular model, but based on case, but based on case. Huh. Okay, 768 is the dimension, and what we are able to get over here, the 768 only, and print say embedding, and I just want to have say 5 embeddings only, top 5 embeddings for each and every say token. So this is looking good. Okay. So this is say these are the top 5 embeddings, huh? And it will be similar to our first one basically. 0319 319 probably it has picked from this particular, you can say, embedding only. What I want to show you, embedding is what is being happening internally. Yeah? So say if the LLMs, the LLMs that we are using, these particular LLMs, large language models, are having different meaning of each and every sentence or each and every word with respect to the different situations. What is the meaning of this? Say, if I'm saying I uh, the 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 weight, just try to understand. Let me take from ChatGPT only. Okay, can you share uh, some sentences where one word is having different meaning in each sentence? Okay, so just have a look. I deposit money in the bank, and we I'm just copying these particular examples for the better clarity. Okay, so over here, if you are able to see, I deposited money in the bank. So over here, bank is the financial institute. Then the second sentence is we sat on the bank of the river. Over here, the same word is there. Okay, but the meaning is different. At this moment, the bank is land beside a river. Then the second one, second example, bat. Okay, the player swung the bat and hit a home run. So it is nothing but say cricket bat or say some sports equipment. Then the second sentence, what it is saying, the bat flew out of the cave at the dusk. So it is nothing but flying animal. What is same, the bat, but the meaning is different. How the large language model will be able to understand that I'm talking about, say, cricket bat or a flying bat. You can take the third example. The light in the room, the light, please turn on the light. And the second sentence is the suitcase is very light. Over here, it is denoting weight, and over here, it is denoting say illumination. Okay. So sentence, same word, different meaning based upon the context. Based upon the context. This is nothing but the context. How LLM is able to get this particular context. So it is based upon these particular embeddings. The LLM is able to get the understanding about the context based upon these particular embeddings. And 768, what it means, it is the dimension over here. It is the dimension over here. It means one word in this particular model have 768 different values, and those particular, try to focus over here, and those particular values are picked based upon the context, based upon the you can say intention which is given in that particular sentence. And that's why the large language models are able to understand the context properly, and based upon that these particular LLMs are able to pick the correct information. If, like, say, this particular word light and this particular word light, if these are having the same meaning, we will never get the correct information from the large language model. And based, these particular, you can say, things are picked based upon the embedding. So one word or token is having uh, different weights based upon its dimension. Okay, you can take it into this way. The BERT based uncased model, which is used over here, it is having 768 dimension. It might be possible the LLM, the different LLM, say the GPT-3, that is having 12288 dimension, 12,288 dimensions. Okay, BERT is having 768. Let me mention, BERT is having 768 dimension, 768 dimension, and GPT-3. Okay, GPT-3 is having 12288 dimension. Okay, and let me try to provide you a view, or can you provide the dimensions of different LLMs in a tabular view. Okay, and just have a look. And what I will do, I will copy it and paste it over here. Okay, just have a look. So BERT based uncased, the model that we are using, it is having 768 dimensions. Okay, we'll be talking about layers and the parameters. I used to discuss about parameters. It is having around 110 million parameters. And why this particular number is coming, we will be having the discussion on top of that as well. Then BERT last uncased, it is having this much dimension. GPT-3, I'm looking for GPT-3. GPT-3 is not available. Okay, GPT-2 is there. Let me especially ask for GPT-3. Can you tell me the dimension for GPT-3 and GPT-3 and above models? Above models as well. Okay, so GPT-3 dimension D, that will be having 12288 dimension. Okay, 12288 what I have mentioned. Okay, and these dimensions are not disclosed, probably like the information is not available onto the internet. But yeah, what I can say, we are having enough information. You can say the GPT-2, Llama 2, 7 billion. Okay, and if a particular model, if a particular word is having higher dimension, okay, it means it is having more parameter size. You can take it in this particular way: 18192 dimension, 80 layers, and it is having 70 billion parameters. 8192, again 70 billion parameters. Okay, so based upon the parameter size what the LLM is having, and this particular dimension is playing a critical role over here, and the accuracy of these particular models is also improved once we are having more parameters. and you can say more dimensions. Okay, it might be possible the newer, you can say, joiners will be able to consume it 70 to 60, 60 to 70%, but no need to worry, just have a look. Okay, these particular things will be discussed in detail in our upcoming sessions. I just want to give you a view like 768, this is a dimension. It means one word is having different 768 meanings, and that particular meaning is denoted by this particular feature which we have extracted over here. So these are nothing but the features for a particular word or token. Word is converted into token, and token, each token is having 768 values over here based upon this particular LLM. But based on case is having 768 dimensions, so we are having 768 equivalent, you can say, values, and these particular values are with respect to the different, you can say, context. You can take it into this particular way. Say uh, you can in the initial, you can say, class, I have quoted an example, say colorful Indian festival. Okay, so what is being happening, a matrix is being prepared, say colorful, so I will be getting let me try to check it from what I'm betting. Okay, probably I just want to show you some image over here. Just have a look. Cat, kitten, dog, house. Okay, man, woman, uh, king, queen. Uh, so just have a look over here. Uh, so we are going to plot these particular things onto the, you can say, we are going to prepare a matrix, okay, based upon these particular given values. So man, woman, king, queen. So over here, man to woman and king to queen. So onto, you can say, different axes, we are going to plot these particular things. And then if man is to woman, if man is to woman, then king is to what? So the distance is being calculated from the Euclidean distance calculator or formula, and based upon the formula, the lower distance value is being picked. Okay, so over here, king to queen, this is the lower distance. Man to woman, or man to queen, or king to woman is having the different, you can say, more distance. So man is tends to woman, and king to queen. And over here, same thing is mentioned, say cat, kitten, okay, and houses. So the cat, kitten is having the less distance, so those particular things are captured up. So you can take it into this particular way. Say I'm having this particular sentence, colorful Indian festival, and is say holy, okay, and we are having, say holy Diwali, and say Christmas, or say we can say Bihu, or Bihu, I don't know. Okay, and colorful Indian festival, and then say distance is being calculated over here. So colorful Indian festival is with respect to say colorful. Huh? So colorful, say Holi is the colorful, say the distance is 001. Then is Diwali colorful? No. So what I can say, the distance is say 0.0056 say 25, and then 00 say, and we can take it into the decimals, so that you will be having a better understanding. So this is one dimension, and what I can say, I can take it into just we will be having in this particular way, we will be having, but based on case will be having say 768 values. 768 values will be there. Just try to understand. Probably it will, I'm trying to give you the insight like what exactly is being happening. So this is the 0th value, this is a first value, this is a second value, third, fourth, and then I'm having 767 total 760. So in this particular way, I will be having 768 values. And what I can say, what can be the another value? Say India is say another dimension. Say country, India, UK, okay, and say Pakistan. I'm just talking hypothetically over here, so that you will be able to get the insight. And say 90 India point. Uh, so it will be with respect to this. So festival and uh, then we can have say 00 10, okay, 0.00, say 328, and say colorful Pakistan can be colorful, that is perfectly fine. 0002. Okay, so over here, once I'm talking about the colorful, okay, so what is say colorful, I'm talking about this particular word, I'm not talking about the complete sentence over here. Okay, so first thing is like each and every, at this moment I'm trying to get the embedding. So say with respect to Holi, this is the embedding, with respect to Diwali, this is the embedding. And I will be having 768 values with respect to each, you can say, given word or token. And these particular 768 are the dimensions. Say I have mentioned it Holi, Diwali, but festival can be one dimension. Okay, it will be represented in say multi-dimensional view. You can take it into this particular way. Multi-dimensional view will be looking like this. Uh, Over here it is represented into two dimensions only. Say colorful is one, and second one is say this particular dimension. So it, once I'm going to represent it into multi dimension, it will be looking like this. Multi dimensional view. What I'm adding, multi dimensions array or model. Let me try to provide you the insight like how it will be visible, so that you will be you will be able to correlate what is being happening internally. I just want to provide you the visuals. They're not given over here. So I'm having certain research article. Let's see, like we will be able to see it in multidimensional view. It is not there. Mm, bookmarks. What embedding from? Just have a look over here. So at this moment, we are talking about two dimensions only. Say gender is one dimension and age is the another dimension. Okay, and with respect to these two dimensions, we are mentioning these particular values. Say if gender is there, say boy is one, girl is another one. So these particular two values are placed somewhere onto a particular matrix, and age is the another factor. Say if the age is less and gender is say uh, male, so it is boy. Okay, and if age is more, it is man. Same the girl and woman. So we are able to see it onto the two axes. So we are having these particular values in the same way, like say we are having another value addition, say child, infant, child, and adult. So this is the matrix what we have prepared. Now, when we are having another dimension, say royalty is the another dimension. Okay, so we are going to calculate the relations of different uh, dimensions. So age is one dimension, gender is one dimension, royalty is another dimension, probably country. We human eye is able to visualize into three dimensions only. Apart from three dimensions, we will not be able to visualize it. So you can take it into this particular way. Our tokens, these particular tokens are into 768 dimensions for this particular LLM. Now, we will be able to calculate the distance, say if colorful is there, into 768 dimension, which one is nearer to colorful. Okay, and we are going to do the calculation based upon this, and then we are going to predict the next word. And because of this particular stuff only, the large language models are able to you can say understand what are you mentioning. They are able to get the context. Okay, that we are talking about, say holy festival over here. Probably you are having the visibility at this moment. You are able to, probably you are able to visualize how the things are happening. So we are having some words. So say colorful Indian festival, this is given over here, and with respect to this, we are having different dimensions and we are trying to capture the weights. Just we will be going through with this. Say we are trying to capture the distance, basically man to king, and uh, this is say this will be looking like this. And then once we are going to have these particular, you can say calculations and all, and at the end we will be able to get these particular numbers. If you are able to see, these are numbers, how these particular numbers are coming, and this is similar to like this only. Okay, so we will be going through with this particular stuff, but at this moment I just want to give you a heads up, like the numbers that we are getting, these are not say the random numbers. These are calculated or generated based upon certain, you can say formulas and uh, say flow, and then we are able to get, and these particular numbers are are having values, different values based upon a given word, and the meaning of these because of these particular values only, this colorful can have different meaning based upon the context. Colorful Indian festival, at this moment colorful is denoting, say we are talking about festival. Okay, say if I'm saying, say, post rain, I saw a colorful rainbow. Okay, colorful at this moment is, say, the context is, say, rain and all. Okay, so colorful word can have different meanings into different, you can say, context, and how that particular information is captured based upon this particular word embedding, you can say, uh, formulation. We will be having the detailed discussions, so how these particular numbers are coming, but I just want to provide you certain insight, like what is being happening internally once I'm trying to extract features from a large language model. Hopefully, you are able to understand something. I'm taking a pause over here. If you guys are having any confusion, then you can ask. If you are able to understand 60 to 70%, that then it's fine, because we will be covering these particular things in detail in our upcoming session. At this moment, what we are trying to do, we are trying to just perform certain tasks and trying to get the understanding about those particular tasks. We have discussed in detail, like what exactly is being happening in feature extraction, what are the different phases. But in the you can say initial days, that particular depth is not required, because you are new to system, you need to understand the things. But what are the different things that are there in our plate that we need to think, we need to have. So I'm talking from that particular perspective. Guys, anything that you want to ask, Yogendra,
Yes,
Vipin?
sir.
Yep.
Sir, this embedding example you have shown for only one word. So the complete sentence, maybe you will explain in next sessions, like colorful, and then you will use a festival, or we can use some other thing also. Are you
Correct,
getting my
correct.
point?
So just try to understand. One word is having 768 values over
Yes, sir.
here. That is based upon the LLM what we have used, but based on case, it is having 768 dimension. Okay, so each and every word is having 768 values. Now, this is the embedding phase only. Yeah? Okay, this is the embedding phase only. We will be post embedding. There is the attention phase. After attention, there will be MLP phase. Attention is going to retain the context from the. I used to say, like I have discussed, the attention mechanism inside the transformer, which is going to retain the context from the given word, or given, you can, sentence or given paragraph. Attention's task is to retain the context. How that context is retained, that we will discuss. Definitely, we will be having detailed session. Transformer is a lengthy topic, and it will take 4 to 6 weeks basically to go through with the complete transformer architecture. But that is there in our plate. You just need to understand at this moment, one word is having 768 different values based upon the model utilized. If I'm using GPT-3 at this moment, the word will have 12288 values. Correct? If I'm going to change the model, the dimension will be changed. That is mentioned over here as well. Huh? Okay. So, but based on case, 768 dimension. But last on case, 1024 dimensions. Okay. GPT-2 XL, 1600 dimensions. So once the model is changing, the dimensions of a particular token is being changing. Correct? Vipin, is it clear?
Yes, sir. No, sir. My
Perfect.
query was that for that, in that particular example you have shown, like
Mhm.
regarding colorful, the
Mhm.
holy might there might be some other words which are more nearer to the zero, other than holy. I mean to say.
Mhm, mhm.
So but the when you will make the complete sentence like colorful festival, then I think the Holi will be the nearest. So that thing you will explain later, or but just I was that was asking.
Yes. So how the
How that thing work?
next,
How that thing
yeah,
work basically?
yeah,
That I
yeah.
want to.
So over here, we have seen this particular head as well, Polo Club. This is going to explain the transformer. And you have seen inside the feature extraction, you have seen just this particular part. So embeddings. You have seen this particular part only. Okay, you are having data visualization empower users too, and you are having just the tokens and all. Okay, tokens and then embeddings. Okay, and we haven't came to the attention mechanism. We have just seen the embedding piece only. Correct. We haven't seen, we have discussed about embeddings only. Correct. And if you are able to see, visualization empowers users to see, or to see is the next word which is being picked.
Okay, sir. Okay.
Indian festival. So how Holi was picked based. So we have discussed about the embedding so far, and how the Holi and other, you can say, words are predicted. This is based upon the transformer architecture. Correct, Vipin? We have discussed about the embedding.
Yes, sir. Yes, sir. Okay.
Embedding. Over here, like this is tokenization and post positional encoding and all. So embedding is being discussed so far, and the transformer architecture, if you are able to see, so that is having two phases, like the attention mechanism and the MLP. Okay, so what is being happening in
So
MLP?
your screen is not visible.
Is it? Is it with everyone? Uh-uh.
Yes, sir. Not visible currently.
Yes, sir. Not visible. Mm-hmm. Okay, I have reshared it. Okay, so we have discussed so far about the embeddings only. Okay, so say over here, like it is not in depth basically. It is just try to show you like what is the meaning of this transformer architecture. But embedding is something like we will be having the different values and all. and inside the transformer block, say the key value and key query and value matrices are there, and then the formulas and all these particular things will come into the picture. We will be having a detailed discussion based upon this transformer architecture, which is coming after the embedding phase. Then we will be able to predict the correct, you can say, sentence, oh sorry, word, and we will be able to get the intent, and based upon that intent we are able to generate the new content. Correct? Making sense? Vipin,
Yes, sir. Yes, sir. Okay.
Yogesh, sorry, Yogendra, Lakshmi, Nikhil.
Yes, sir. Correct, sir.
Perfect. Now, so this is nothing but say the feature extraction. Now, what I can do, I can utilize, let me try to pick a model from here and say OpenBMB Science Optic Omics. So a tri-model foundation unifying historical, spatial transcriptions and biological language. What this model is doing, I just want to check what this particular model is doing. Image only reasoning, no, we don't want image and all. So feature extractions models. And this is non-distributed Q prime commercial quantum structured embedding model for regulated AI. Model weights, this is perfectly fine. Organization Q prime. Is it downloaded? No. Quen 4 billion parameter. Parameters are too huge. Let me try to copy this one, and let's see, like, and I just try to mold it a little bit. Extractor say 2 pipeline feature extraction and model equal to this, and let me try to check it out. Okay, so just have a look. Now the model downloading is started, right? It is not there in my machine. So model 1, model 2, it is being downloaded. Correct? Guys, are you able to see?
Yes, sir. Yes, sir.
Yes.
Okay.
Yes, sir.
So the model is being downloaded. The distill bird based on case was available in my machine, so it was not downloaded. But over here, it oh, this is too much. So let me try to cancel it. It is going to occupy a lot of space. So 4.9, almost say 5 GB and 8 GB. This particular space will be, you can say, there in my machine, and it will be huge space basically. I don't want to have it better, like I can utilize it with the help of say embedding, oh sorry, APIs and all. I don't want to download this model on my local machine because the size is huge over here. Correct? So we just need to keep on checking like what is the size of this particular model if it is really required, because we are running on a machine which is having the limited capacity. It is not like we are having a server, full-fledged server, which is having a lot of, you can say, configurations, huge configuration. But we are having the limited configurations. On limited configuration, I don't want to you can say utilize it, because this particular 8 GB, almost the 8 GB stuff will sit inside the memory of my machine, and then from the memory it is going to do the inference and will provide me the result, and I will be in hang situation. The situation what we faced previously, it is because I have downloaded multiple LLMs in my machine, and it is uh, that is, you can say, the performance has been degraded at this moment for this particular machine. So I need to do optimize. I need to optimize the configuration. I need to remove these LLMs which are not really required. So that can be there, but as we are going through with the learning phase, so probably we should like pick a small model, do the analysis on top of that model, and then remove it as and when required. Okay, I think that's it for this particular session. We have seen feature extraction in detail. There are certain other tasks as well, and in tomorrow's session, I will pick one or two tasks, and uh, we'll cover those particular tasks, and we'll start the new, you can say, stuff as well. Okay, and so that's it for this particular session, guys. If you are having any query, you can ask. Anything that is there in your mind, Vipin, Vikas, Yogendra, Lakshmi, Nikhil?
No, sir. All okay.
Perfect, perfect.
Awesome.
So
All good.
thanks, guys. Thanks for joining. Have a good day.
Thank you, sir.
Thank you.